going out of business. Still not happy. But we're doing math, so that makes me kind of happy. Woo! All right, kids, we're on day 4. Day 4. Sine formulas. Sine formulas. So, do me a favor. You should have this sheet already. If you don't have it printed, go to www.mrkrausmath.com. Let me put that on there. www.mrkrausmath.com. And this is day 4. Look for Unit 8, day 4, under your particular set. You should have it printed out. Now, this first page, I'd like you just to go through it on your own. Don't use me. You should be hitting the pause button right now. You can pause it right now. That was a good place to pause it, wasn't it? You can take a little screenshot, tell everybody how cool your math teacher is. That was my cool face. All right, pause now. You should have been paused. Now we're back. All right, great. Sine of A equals 9 over 41, and we're in quadrant 2. Okay, this is from the last unit. Go, boom, boom. We're going to quadrant 2. We draw a 90-degree angle. Probably going to need my calculator because that's huge numbers, humongous numbers. Let me just get that going. So, cosine, you'll recall, or sine is opposite over hypotenuse. So if this is my angle, this is opposite, this is hypotenuse, and this is my missing side. So I'd go, okay, x squared plus 9 squared equals 41 squared. X squared plus 81 equals, we're ready to go, maybe. Close. Let's see, 41 squared, somewhere like 800, oops, I should probably go on the calculator. 41 squared, something like 881 or something like that. Oh, 1681, 881, what am I, crazy? So 1600 and, was it 1681? Oh, then we'll subtract 81. So I get x squared equals 1600. So just as I suspected, x is 40. Let's take the square root of both sides. So cosine is adjacent, which is 40, over hypotenuse, which is 41. But of course we're in the quadrant 2, and in quadrant 2 cosine is negative. Tangent is also negative in this quadrant, and it would be opposite, which is 9, over hypotenuse, which is 40. Little something from the last one. Let's do one more. This one I gave it to you a little bit easier. Except now you have to figure out what quadrant you're in. This is 180 degrees. This is 270 degrees, so we're clearly in the third quadrant. In the third quadrant, cosine and sine are negative, but tangent is not negative, it's positive. Cosine is 4 over 5. You guys know that this missing side then must be 3. Therefore, let's see, sine is opposite over hypotenuse. We already have the negative there, so we're negative 3/5. Tangent is opposite over adjacent, which is 3 over 4. And it's positive. All right. I don't know why this thing insists on breaking this one up into pages. But really quickly, make sure you go through all of these and do these. Sine of 130 degrees is 1/2. Cosine of 30 degrees is square root of 3 over 2. Sine of 60 is square root of 3 over 2. Cosine of 60 is 1/2. Do you have it? I hope so. Sine of 45, square root of 2 over 2. Cosine 45, square root of 2 over 2. Sine of 135 has a reference angle of 45 degrees, so that's square root of 2 over 2. This is in quadrant 2, and sine's positive. 240 has a reference angle of 60, so 60 is cosine of 60 is 1/2, but we're in the third quadrant, so that's negative. 210 is in the second quadrant. Down here, reference angle of 30. Sine of 30 is 1/2, but we're in the third quadrant, so it's negative. 270, oh, what am I drawing? A fraction line. 270 is one of my quadrantal angles, and the sine of 270 is just -1. 330 is 30 away from 360, so this is a reference angle of 30. Cosine of 30 is the square root of 3 over 2. We're in the fourth quadrant, and cosine's positive in the fourth quadrant. This has a reference angle of 45, so therefore it's the square root of 2 over 2. In the fourth quadrant, cosine's positive. All right. Hopefully you got through all those. Now, looking through this sheet. I said blue. I think I actually made them this year in yellow. So anyway, these formulas, you'll notice, are on your formula sheet. All of these formulas are on your formula sheet. And over here I said, okay, what are these A's and B's? What is, I see an A here, a B, A's and B's, more A's and B's. What in the world are these A's and B's? What are they all? Well, they're angles that you like. And what are the angles that we like? We like 30. We like 45. We like 37.25. No, we don't. That certainly isn't one we like. That's awful. We like 60. We like 0. And we like 90. Those are kind of like the angles that we like. There's a few more formulas. These are the double angle formulas. We'll come back to those. And the half angle formulas. We'll come back to those when we get to those problems. Oh, it's about to get for Rizzle. And when it gets up for Rizzle, you go to the bankrupt Brugger's Coffee for a delicious cup of coffee. All right, you guys are too young for delicious cups of coffee. Let's go to page 3. And this is what I got to do every page now, because for some reason, just this one came out. Oh, let's see. I see big words that say exact. Let me give you the Webster's Dictionary of Exact. Well, Krauss's Webster's Dictionary of Exact. The definition of exact is, if you give me a decimal, I will cry, or get mad, or flip out, or pull all my hair out. Oh, wait, hold on, I can't do that one. I am going to get crazy mad. Crazy mad. Crazy. I should have put crazy mad there. I'll flip out. I might actually cry. You'll be so mad. Can't give me. Like, I can go to my calculator and go, okay, calculator, I'm going to come over here and type in sine of 15. And I know the answer is 0.2588190451003. Oh, Mr. Krause will be so proud of me. Oh my God, that was a rhyme. That was awesome. So what do we have to do? We have to make up 15. Huh? Yeah, it's not that bad. We got to make a 15. Now, the only cool part about this is I'm going to give you angles that you kind of like. Or I'm going to give you kind of angles that you can work with. So I need to make 15. What you talking about, Mr. Cruz? Parents will understand that one. Well, let's think about the angles we like. We like 30. We like 45. We like 60. We like 0. We like 90. Can I make 15 with any of these? Oh, yeah, you can. I'm going to use these two. Now, I could use these two, or I could use these two. Either case, aren't these 15 away from each other? Isn't the difference of these 15? So let me rewrite this. Sine, ooh, look how nice that S was, of, I'm going to make 15 by doing 45 minus 30 degrees. Well, I like 45, and I like 30. So that's not bad. Except what the heck do I do now? And if you distribute, this is not distributing, kids. You can't do this. It's like if you have f of x plus 2 and you say, oh, that's the f of x plus the f of 2. No, it's not. No, it's not. Not even close. You plug x plus 2 in. So what do we got to do? We got to use our formula sheet, which of course is now shrunk. And we need to find subtraction of two angles. Sine subtraction of two angles. There it is right there. There's our formula. It's on our formula sheet. So what we're going to do is we're going to say, okay, if I have, let me blow that puppy way up. Oh, man, that was too much. So if I have the sine of two angles that I'm subtracting, this is the formula I want to use. You take the sine of A times the cosine of B, that felt better, minus cosine A sine B. So, I forgot what I was doing. So, the formula is the sine of A times the cosine of B minus cosine of A times the sine of B. But Mr. Krause, I don't have an A and B, so sorry, can't do the problem. Oh, we need to bring out the cool pen. Oh, we're bringing out the cool pen. The cool pen's coming out. Then I'm going to bring the purple cool pen. This is A, and this is B. So everywhere you see an A, we're going to put 45. And everywhere we see a B, we're going to put 30. Oh, I get it. I get it. So this is really the sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. It's about right, kids. All right, well, what do I do now? Ooh, well, we bring out the cool purple pen because we're ready to rock and roll. What is the sine of 45? Oh, yeah, that's the square root of 2 over 2 times 1/2. Yes, Mr. Krause? I see fractions. I don't like fractions. Fractions scare me. I'm scared of fractions. The fractions are scary. Stop talking. You gotta love the fractions. The fractions are our friends. Lots of fractions today, kids. Lots of fractions. But the good news is they're not bad. And they're almost all the same. Cosine 45, square root of 2 over 2. Times the sine of 30, which is 1/2. Look familiar? Not bad. Let's go. When you multiply fractions, you multiply the numerators, square root of 2. And you multiply the denominators, 4. Minus, multiply the numerator, square root of 2. Oh, guys, Krause made a big mistake, huge mungus, and I know you caught it. I know you caught it. It's right here. Cosine of 30 is not 1/2. The cosine of 30 is the square root of 3 over 2. That was dumb. So anyway, everybody makes mistakes. So when you multiply across square root of 6, because square root of 3, 2 times 3 is 6, all over 4, minus the square root of 2 over 4. Well, now that they have a common denominator, we keep that denominator 4, and we subtract the numerators. Square root of 6 minus the square root of 2. Done! Yeah, you can't put those together. They're not the same radical, so they can't be put together. Well, let's see what that looks like. Let's see if you said it was the square root of 6 minus the square root of 2 all over 4. Oh, look, the decimals match. There's a quick check to see if you're right, but don't give me the decimals. It'll get ugly around here. You don't want it to get ugly. All right, we're gonna start moving now. So let's see. I want to know what the sine of A and B are. Okay, now I'm going to use the sum formula. It's actually telling you, hey, use the sum formula. So let's go back to the sum formula. Sum formula is right here. We're going to use this formula. Well, this is the same exact as the cosine formula. The only difference is we're going to add when we do the sum formula. So it's sine A, cosine B, cosine A, sine B. What am I doing? So let me blow this up so you can see it. Bing, bing. That might be too much. So there's a ton going on here. There's a lot more than you even know going on here. So let's see what we got. We're going to use this formula. So the formula is sine of A plus B is equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. Now, what we got to do is figure out if we know any of these. Well, we know the sine of A is 15 over 17. And we know the cosine of B is negative 4 over 5. But we don't know either of these two. We don't know. We got a little bit of information. So here's our little bit of information. Let me get rid of some of the stuff from before. We see here that A is between 0 degrees and, what is this? 90 degrees. So that means A is in quadrant 1. B is between 180 degrees and 270 degrees. That means B is in quadrant 3. So let's see how that works. Let's do A first. Quadrant 1A. And I know that sine is 15 over 17. Opposite over hypotenuse. So if you do the Pythagorean Theorem, you'll find out that this is 8. Because 8 squared plus 15 squared is 17 squared. So what don't I know? I don't know the cosine of A. The cosine of A is 8 over 17. And since we're in the first quadrant, it's positive. Now I'm going to do B. Well, I said B was in quadrant 3, so I got to come down here and draw a triangle in quadrant 3. And I was given that cosine is 4/5, adjacent over hypotenuse. And again, if I use the Pythagorean Theorem, this is 3. Well, the sine is opposite over hypotenuse, which is 3 over 5. But we're in the third quadrant, and in the third quadrant, this is negative. So here's what I get. 17 times 5 is 85. 15 times negative 4 is negative 60. Plus 85. A negative 24. So here's what I get. I get negative 84 over 85. Yay! Done with that problem. Find the exact value of cosine or sine of 2a. Sine of 2a. Well, that's really weird. Huh. I wonder if I have a formula for that because it's so weird. I wonder if I have a formula for sine of 2a because it's so weird. 2 times a. 2 times a. When you multiply by 2, isn't that doubling? Double. We're going to double. Double. Oh, gosh. Look at that. Double angle formula. There it is. My double angle formula. Anytime you get something weird, kids, go to the formula sheet. Probably there. The double angle formula says the sine of 2a is equal to 2 sine a cosine a. Forgot I just have to go back. Oh, this is annoying. So hopefully my other ones aren't going to be like this. All right, so the sine of 2a is, the formula says, it's equal to 2 sine a cosine a. Okay. Now, I have a quadrant 3 angle, so I'll draw my quadrant 3. And there's my angle theta. Let me get a different color now. And I'm given that cosine is 24/25. Now, I'm pretty sure this is 8, but I'm not really sure. So let me go x squared plus 24 squared equals 25 squared. I know this is 625. I think this is 596. I don't remember. 24 squared is 576. Excuse me, 576. 576 x squared. Subtract the 576. And I get 49. Oh, it's a 7. So x squared equals 7. So that 49. So this is 7. All right. So now I'm really ready to rock and roll. So sine of 2a is equal to 2 times the sine of A. Well, the sine of A is 7 over 25, but we're in the third quadrant, so it's negative. Times the cosine of the angle, which we were given, negative 24 over 25. And then all we do is just multiply all this stuff. Probably go over the calculator. 2 times negative 7 divided by 25 times negative 24 divided by 25. I think this is going to turn out, look, oh, see that? That actually might be the right answer. That actually probably is the right answer, but this is not what I was looking at. So let's do this the right way. 2 times, I got to make sure, control division, negative 7 over 25. 2 times control division, negative 7 over 25 times control division times control division, negative 24 over 25, negative 24 over, why does it keep doing that? Negative over 25. All right, it is in fact the right answer. 336 over 625. Okay, I'll take your word for it. There it is, kids. 1, 2, 3. We're going to 5. Question 5. View. Now, again, this is one we've similarly done, so if you're feeling pretty confident, think if you can think about something we've already done to try to do this problem. Sine of 75. 75 is not an angle I like. So what I want to do is try to get this to be an angle I like. This is not an angle I like. What are the angles you like? You like 30. You like 45. You like 60. You like 0. You like 90. Can I make 75 with these? Sure you can. It's right here. So we're going to call this the sine of 30 plus 45. You're going to go over to your formula sheet and you're going to say, oh yeah, that formula sheet says it's sine of A cosine B plus cosine A sine of B. And then you're going to try to remember using your cool pen, because you got your cool pen out now, that this is A and this is B. So we're going to do sine of 30 times the cosine of 45 plus the cosine of 30 times the sine of 45. We're almost done, chillin'. We're at the end, yay! Well, we're almost done with this problem, not the end. Work. Ding, 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 blink, 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 blink. This is 1/2. Square root of deuce over 2. This is the square root of 3 over 2, and this is the square root of 2 over 2. You'll notice this looks familiar. So we get the square root of 2 over 4 plus the square root of 6 over 4. And when we add all that up, we get the square root of 2 plus the square root of 6 all over 4. There's our answer. Next problem we're going to do is 6. Why am I doing 6? Oh, 6. Oh, damn. Oh, this didn't come out nice. This should be 13 pi over 12. Oh, my goodness. What is that? What is that? Seriously, what is that? That's just redonkulous. So first thing I'm going to do is figure out what in the world 13 pi over 12 is by multiplying by 180 over pi. Pi's cancel. And I end up with 195 degrees. Let's see. Maybe that's an angle I like. If that's an angle I like, I'm finished. Let's see. 195, that's right here. That'd be 15. Oh, it's only 15 away from. It's not one I like. So I have to make 195. Now, you got to think, what can I make to make 195? Well, I'm going to give you a little hint. If there's a 5 in it, one of the angles has to be 45. And we're going to add to that some other angle that will give me up here. So if I come over here and I say, okay, if I know I have to use 45, I'm going to subtract 45 and I get 150. But Mr. Krause, 150 is not one of our nice angles. We don't like that one. We only like 0 and 30 and 45 and 90. Oh yeah, and we like 62. I know, kids. I know. But 150 is not bad. Remember, a 150-degree angle is right here. Now, it's not the 150 I like. It's the reference angle I like. And the reference angle is 30. Oh, that is one we like. So when I go to do the sine or cosine of 150, what I'm really doing is the sine of or cosine of 30. And then I have to remember what quadrant we're in. Remember, this is in quadrant 2. So we're going to use the sine sum formula. Sum formula says sine of 45 times the cosine of 150. Remember, this is A, this is B, plus the cosine of A, which is 45. Remember, this is A, times the sine of 150. This is B. All right. Well, cosine of 45, that's easy. You know. Even Holly can get that one. She ain't got anything. JK, Holly. It was a lot of fun to joke with you. Square root of 2 over 2. Square root of 2 over 2. That's not bad. That's in the first quadrant. It's positive in the first quadrant. Now, I know cosine is negative in the third quadrant, and sine is positive in this quadrant. So put those signs in right away, then I don't have to worry about them. So now I have to think. The reference angle here is 30. What is the cosine of 30 degrees? And the cosine of 30 degrees is the square root of 3 over 2. And what is the sine of 30 degrees? Well, sine of 30 degrees is 1/2. And we're in the third quadrant. So let's multiply. We get negative radical 6 over 4 plus radical 2 over 4. And this is negative radical 6 plus radical 2 all over 4. Ooh, it looks so familiar, Mr. Krause. All right, let's move on. So next problem I want to do. Next problem I want to do is, that was 6, right? Next problem I want to do is 8. So I go over here. I got to blow the page up. Bing, 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 bing. Not really blow it up, you crazy people. And I got to... Whoa. Whoa, 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 whoa. Let's back up the crazy train. Crazy. We just got to make negative 165. Well, that's not a problem. I know it has 120. I know it's got a 5 in it, so I know I got to use like negative 45. And then I'm going to add to that. What do I add to that? 45, take 45 away. You get 120. 100, a negative 120 degrees. That looks complicated. I don't even like that. Ew. Ew. That's ugly. Let's try to come up with a different way to do that. Because I don't like that at all. I mean, that's going to be nasty. All these negatives and positives. I'm going to take the sign of negatives. Let's see if I can come up with a different way to do that. Maybe I can come up with a different way instead of adding, because I was trying to add those together. Let's try subtraction. We know we got to use 45. So maybe we can take 45 and we'll take, let's see, how far away? 45. Let's do, how about we subtract off 200? Well, that would be negative 155. That's close. We got to go 10 more. So how about negative 210? Oh, wait a second now. 45 minus 210, that would be negative 165. But I wonder if 210 is one of my nice angles. Hold on a second. 210 degrees. 180. A little bit more. 210. That's, oh yeah, that's 30. So that's one of my nice angles. All right, kids. So it's kind of a guessing game. You got to play around with it. Come up with some numbers that work. In this case, 45 minus 210 works. So I'm not going to use the sum formula. I'm going to use the subtraction formula. And the subtraction formula, or the difference formula, is sine of 45, or A, cosine of B, 210, this is B, minus, that's where the minus comes in, that's the only place, the cosine of 45 times the sine of 210. A and B again. All right. So let's see. Sine 210 is in quadrant 3. So I know that in quadrant 3, both cosine and sine are negative in quadrant 3. So I got to remember that. So this is the square root of 2 over 2. Let's see. What my reference angle was 30, and the cosine of 30 is radical 3 over 2. So that's negative radical 3 over 2. Cosine of 45 is square root of 2 over 2. And the sine of 30, remember we're going to use the reference angle, is 1/2, but we're in the third quadrant, so it's negative 1/2. All right, this is a mess. Negative radical 6 over 4 minus negative radical 2 over 4. We'll see these two minuses. They make a plus. So this is equal to negative 6, square roots of 6, plus square roots of 2 all over 4. Now the good news is that's a lot of work, but I can test my answer. Come over here and do sine of negative 165, enter. And then I'm going to do controlled division, negative square roots of 6, plus the square root of 2 all over 4 equals. See how the answers came out to be the same? So I was right. So 8, we're going to do 9. I don't know why. Oh, we got another double angle formula. So you see where it says 2 theta? As soon as I see this, formula sheet. And so if you remember the sine of 2a, the formula is 2 sine a cosine a. Okay, great. Should be easy. 2 sine a is, well, what the hell's a? Oh, we're using theta. Oh, maybe I should just use theta this time then. Doesn't matter what you call it, but you probably should be consistent. I know the formula sheet says a. All right, so I know cosine, it's 8 over 17, but I don't know anything about sine. All right, let's see what quadrant we're in. 0 and 90 degrees. That's quadrant 1. So I'll draw a triangle in quadrant 1. Cosine is adjacent over hypotenuse, 8 over 17. And just like before, this is going to be 15. It's that 8, 15, 17 triangle. Comes up a lot. So sine is 15 over 17. All right, we're almost done. Multiply. 17 times 17 is 289. Do it on your calculator if you want. 2 times 15 is 30. 30 times 8 is 240. And again, you could just put this in your calculator if you want to, but you'll get that answer. All right, kids, that was 8. That was 9. 1, 2, 3, 4, 5, 6 more to go. Going to 10. Oh, I'm losing my voice for some reason. I don't even know why. So, find the exact. Don't use your calculator. No decimals. Oh, got another double angle formula. You got to figure out what quadrant we're going to go into. What quadrant are we in? This is 90 degrees, and this is 180 degrees. So X is in quadrant 3. That's 9 between 9. Oh no, quadrant 2. Between 90 and 180 is quadrant 2. All right, so let's see what we got here. So X is in quadrant 2. And sine is opposite square root of 7 over hypotenuse, which is 4. We're missing this side, so we'll go x squared. Oops, that's behind my head. Just going to do this math. X squared plus the square root of 7 squared equals 16 squared. X squared plus square root of 7 times square root of 7 is just 7. And I don't know why I put 16. It should be 4 squared. That's jumping ahead. Is equal to 16. x squared is equal to 9, so x is equal to plus or minus 3, but since we're working in a triangle, since we're working with sides, this will be just 3. So, let's see, can I get that up a little bit? Yeah, that's away from my head now. So, I want to know the sine of 2x. So, the double angle formula says the sine of 2x is equal to 2 sine x cosine x. In this case, 2 cos... Oh, I was given sine x. Sine x is the square root of 7 over 4. Wait a second. Oh, yeah, we're in quadrant 2, so sine is positive. But cosine is negative in this quadrant. So, yes, cosine is 3 over 4, but we're in the second quadrant, so it's negative 3 over 4. All right, now let's multiply this stuff out. The denominator is just 16. 2 times radical 7 times this. This is going to be negative 6 radical 7 over 16. Wait a second. That can be reduced. Now, you don't necessarily have to reduce it, but it can be reduced. It's equal to negative 3 radical 7 over 8. That would be the reduced formula. But whatever. That was 10. Let's go to 12. It's on the same page, I hope. I think this is 12. Let's write that. 2 sine of pi over 8 times the cosine of pi over 8. Wait, 2 times sine of an angle times cosine of an angle. That sounds familiar. 2 sine of an angle. Didn't I just do something like that? 2 sine of an angle cosine. This is 2 sine of an angle cosine of an angle. It's a different angle, but it's still an angle, right? So this is 2 sine of some angle cosine of some angle. Wait a second. That's just the double angle formula. That's just the sine of 2 times the angle. Oh, whoa, we got to work backwards? We're going to work backwards. So wait. So the angle in this case is just pi over 8. So really this is just a double angle formula, but I got to work backwards. Oh, okay. Well, this is really just the sine of 2 pi over 8. Well, 2 pi over 8 can be reduced, so that's really just the sine of pi over 4. And the sine of pi over 4, well, wait a second. That's just really... now, half of you guys get it now, right? You got it. But pi over 4, we're going to multiply by 180 over 4. All of you are over pi. All of you know this is a 45. So this is really the sine of 45 degrees, which is radical 2 over 2. So sometimes you have to work backwards. You're going to look at something. It's going to look funky, but you'll have to work your way backwards. You'll see we're going to do a couple of them like this. Not too many, but a couple. Let's take a look at 13. 13's on the next page. So go... Man, it's cold in my basement. I'm in my basement, by the way, just in case you're wondering how much I'm struggling. I'm so cold right now. So let's see what we got here. Let's see if I can blow this up just a little bit more. So x is the measure of a positive acute angle. Okay, so x is acute. Key little angle. That means it's less than 90 degrees, right? Less than 90 degrees. I know that the cosine of x is equal to this. I want the exact value of whatever this is. Sine of 1/2 x. I know what x is. Well, I can find x. I can do this. Let's do this. Go to my calculator. You just bring the cosine over, so I can do inverse cosine of 7 divided by 32, and I get 77-degree angle. I want half of that, so I'll divide that by 2, and I get that. Ooh, yes! Then I'll take the sine of that, and I get, yes, 0.625. There's my answer. No decimals, dummy. Come back to page 2, chillin'. Let's blow this sucker up. All right, we're going to go over this way. We're going to come down here. Half angle formulas. Half. 1/2. Oh, I got a half angle formula. So if I see something that's a half, I just got to use this. So half sine of half A is equal to plus or minus the square root of 1 minus cosine A all over 2. Let me see if I can write that down. What page was I on? So it's equal to plus or minus the square root of 1 minus cosine of x all over 2. Let's see if I got that right. 1 minus cosine of the angle over 2. I think I got it right. So let's go back to page 7, blow it up. So let's see. This is going to be plus or minus 1 minus. Now the cosine of x is 7 over 32. All over 2. Well, if I use the radical, there's a chance that I'll get some decimal, and I don't want a decimal, so maybe I just have to leave it in radical form. The denominator is just, well, man, I don't know what this is. This is craziness. So let's see what we got here. Let's go to our calculator. What we're going to do, and here's what I would like you to do. I want you to type in all of the stuff that's under the radical, but not the radical, because, you might end up with some weird number. So let's just type that in. Control division. 1 minus control division. Whoa. I need a new calculator. Control division. 1 minus control division. 7 over. Gotta love this silly thing. What the heck? 7 over 32. I could have done like half the time on my own calculator. 2 is equal to, 25 over 64. So it's equal to 25 over 64. Okay, so really the square root of, so this is plus or minus, the square root of 25 is 5, and the square root of 64 is 8. So I have here is plus or minus 5/8. But now let's think about something. It said angle x is a positive acute angle. So half of x, so if it's less than 90, half of it would still be in quadrant 1, right? So can I have anything negative in the first quadrant? I can't. So the answer in this case, even though I had a plus or minus, the answer is 5/8. So one of the last things you're going to have to do is figure out where x is when we're done with the problem. So here's what we got. We got an angle. I didn't know where it was, but I knew that it was in this quadrant. Somewhere in this quadrant here. So in this case, it could be like 80. Well, if I take 80 and divide by 2, I get 40. I'm still in quadrant 1. So when we're done with these half angle formulas, you're going to have to decide whether or not we take positive or negative. That's going to be one of the tricky parts of this whole thing. What number was that? 10? Let's go down to 12. No, we're going to do 14. So I show you what I'm talking about. So we're going to show you what I'm talking about here. Wait, did I just do 13? Oh yeah, 12, 13. Okay, so now I'm going to do 14. So I know I have this half angle. I see it here. Now I know there's a half angle formula, and that half angle formula is plus or minus the square root of 1 minus cosine x, or whatever you're going to call the angle, all over 2. this gets put in here. Oh, by the way, this is 1/2 x, sorry. So sine of 1/2 x is equal to plus or minus 1 minus -7/18 all over 2. So now they got to do that in our calculator, and I think we had something similar to that. We had this. The only thing we didn't have was this thing in parentheses. Was it 7/32? Oh, it's 7/18. So it's a little bit different. Get rid of that. Oops. Love my computer sometimes. All right, so we'll delete this. Make this 18. And it was negative. So 1 minus -17/18 all over 2. Oh, what? 25/36 again? Weird. So this is going to be equal to plus or minus the square root of 25/36, which is plus or minus 5/6. So that appears to be my answer. It appears to be my answer. But now I have to make a decision, and this is the tricky part. My angle is in from 180 to 270. My angle is in this quadrant right here. The lowest it could be is 180, and the highest it could be is 270. Actually, the lowest it can be is just slightly over 180 and just slightly under 270. So let's use those as my cutoffs, 180 and 270. So I know x is somewhere in between these two. So now we're going to take half of x. Well, half of x, if x was 180 or a little more, would be about 90. 70 is 135. So I know that 1/2 of x is somewhere in between 90 and 135. So in between 90, 135 would be right here. Somewhere in this area would be my value of half of x. Okay, so I know then when I take half of x, I'm in quadrant 2. And sine is positive in quadrant 2. So my answer, my final answer is positive 5/6. So we're moving on to 18. So you got a couple to try on like that. Good luck with those. Those are fun. I like them. I think they're fun. We're going to 18. So we're just going to do another one. Oh, we're going to do a subtraction angle. So the subtraction formula for sine A minus B, I just wanted to do another one of these, is sine A cosine B, if you look back on your formula sheet, minus, forgot where I was going. Oh, cosine A sine B. Let's see. A is between 180 and 270. That's the third quadrant. B is between 270 and 360. That's the fourth quadrant. So let's work with A over here. A is in the third quadrant. The only thing I know about A is that sine is 7/25. That would make this, I believe, 21. Let me just check real quick. 7 squared plus 21 squared is 625, right? Nope. It's not 7. Maybe it's 8. Oh. Oh, maybe it's 24. 7 squared, it's 24, I think, plus 24 squared equals 625. Yeah, you just have to do x squared plus 7 squared equals 25 squared and find out that x is equal to 24, not 21. Get my head up, my keister. All right, the other angle is in the fourth quadrant, so we're going to go down over here. This is B. The only thing I know about B is cosine is 12/15. I got to figure out what this is. This is a 3, 4, 5 right triangle, so this would be 9. But you could do the work if you want to. So, let's see. I was given sine of A is negative. Let me do this in a different color. I'm going to do my fun color, my fun blue color. I was given that A is negative 7 over 25. Cosine B? I was given that cosine B is 12 over 15. Now I got to come over here in A. I need cosine of A. Cosine of A is adjacent over hypotenuse, which is 24 over 25, but I'm in the third quadrant, so it's negative. Lots to think about, kids. Sine of B, okay, let's go down to B. Sine of B is an opposite, which is 9, over hypotenuse, which is 15, but it's in the fourth quadrant, and sine is negative in the fourth quadrant. So if I multiply all this out, well, this gives me negative 84 over 375 minus, and negative times negative is positive, 375. What do I multiply when I get those? I get positive 288. And when I subtract these out, I have no idea. I really wouldn't expect you to do it this way. Here's what I would expect you to do. I would expect you to do parentheses, negative 7 over 25. Oops. Divided by 25 times 12 over 15. 12 divided by 15. Now make sure after you press enter, it looks like what you got on your paper, minus parentheses, negative 24, parentheses, I think I did it wrong on my sheet here. Negative 9 over divided by 25. Oops, I forgot here. Divided by 25. So negative 24 over 25, and we hit enter, and I get negative 356 over 625. Yay! We're almost done, kids. What do we got? Oh, one problem left. Number 21. 21. Okay, so simplify, then find the exact value of this. Well, none of these are angles I like. I don't like any of these angles. None of them. Don't make any sense to me. But that thing looks familiar. You got a sine, cosine, cosine, sine. I think I've done something like that. Sine, cosine, cosine, sine. And for those of you that are sticking with me or figuring things out, we're going to work backwards again. So if I'm looking for sine, cosine, cosine, sine, take a look at this formula right here. Sine, cosine, cosine, sine with a plus sign. So sine, cosine plus cosine, sine. That's really the sum formula of sine A plus B. So when I go back to my equation over here, blow it up, and I say, oh, wait a second. This I can work backwards from. This is sine of A, cosine B, cosine A, sine B. These are really, this is really A and B, A and B. So this is really the sine of A plus B. That's the sine of A plus B formula. Well, what is A? Well, A is 20 and B is 25. Oh, okay. Well, that's really just the sine of 45. Well, sine of 45 is square root of 2 over 2. Done. All right, kids. That's it. You have the rest of them to do. Good luck, and may the force be with you.